Okay, so we talk about key management, how we can distribute the public key. If you are in public key setup, how we can distribute the public keys. So in public key setup, everybody has a pair of key, public key and private key, or public key and secret key. So if there are few parties, Alice, Bob, Bimal, Palas. So if they are in public key setup, so everybody has their public key, private key. So this is the Bob public key, then the EP, DP. So everybody is having their public key, private key pair. And now suppose Alice want to send a message to Palas. So Alice has to get Palas public key. So now the question is how Alice will get Palas public key. So how the public key? This is a part of the key management. How we distribute the public key, that is the that is one issue. Now suppose Alice wants to send a message to Bob. So Alice need to get, so this is DA. So Alice need to get Bob's public key, that is EB. So how Alice will get Bob public key? So this is the part of the key management. So the key management in this area we will discuss two distinct aspects, like how to distribute this public key, and we will see how we can, if we are in a public key setup, how we use the public key to share the secret key. So first part, distributing of public key. So how we can distribute the public key? There are basically 4 techniques we will discuss. The first one is the public announcement. So once I have a public key, I will keep on announce. Suppose I have a mic, so I will announce, hey, this is my public key, this is my so that is some sort of public announcement. And the second method is publicly available directory. Inside a public announcement, we can maintain a directory where I can put my public key, and that directory should be in a public domain, so that everybody should able to access it. And the public key authority. So if we keep the directory so public, then anybody can change there and do some changes in that public key. So that will create some problem for the communication. So for that we can have a third party, which is public key authority, and we can ask this third party to maintain this directory. So some sort of trusted authority, the third party, trusted party will be there. And the next one is public key certificate. So if we always ask this third party, hey, give me the public key of Bimal, I want to send a message to Bimal. Then Bob is telling, okay, give me a public key of Palas, I want to send a message to Palas. So there is a bottleneck in the at the third party end, at the public key authority end, who is having the public key directory, because so he has to answer all the queries. So there will be a bottleneck, bandwidth problem will be there. So to solve this, what we can do, we can issue a certificate. So this third party or the trusted party or authorized party, they can issue the certificate to the each users, and that certificate will contain the public key. So if I have to communicate with Bimal, so I will ask Bimal to show his certificate. So Bimal will give me his certificate. So from that certificate I will come to know Bimal's public key. So this is the way we can avoid to communicating with this third party, to avoid that bottleneck. So this is the public key certificate. So let us come to the this is so this is the first part, the public announcement of the public key. So here the public key encryption should be that public key should be public for the public key encryption. So it could be RSA, we can set up the RSA and we run the RSA key generation, and we got the public key, private key pair, and then everybody can announce their public key. So this is S public key, so I keep on announcing my public key. So this is the uncontrolled public key. So it is having the drawback that, so if I keep on announcing, then when I mean I may not sending a message now, and the sender, the receiver is announcing the public key, his or her public key now. So, that is the problem. I may send later on. So, that time maybe the person is, the receiver is not announcing his or her public key. So, to overcome this problem, what we can do? We can maintain a publicly available directory. So, one can maintain a directory like, so it is basically a file. This is a public key directory, public key, sorry, directory. So, PKD. So, it is basically contain the name and the corresponding public key. So, Alice, Bob, Bimal, Palas, and once we have a public key, so we will publish there, we will go to that directory and we will put that value. Suppose this is the public key of Alice, suppose this is the public key of Bob, like this. Okay. So, we will maintain this directory, which is called PKD, public key directory. Now, if suppose this directory is available on a public domain, for example, it could be a website. In a public website, we keep this directory, I mean this directory, this file has been maintained. So, suppose now Alice wants to send a message to Palas. So, what Alice will do? So, Alice will access this directory and Alice will, so this is ePalas, EP. So, Alice will get Palas public key and Alice will encrypt the message using Palas public key and send it to Palas. So, this is the way we have to get the public key of the receiver. So, sender has to get the public key of the receiver. So, what sender will do? Sender will access that public key directory and get the go to that corresponding field where the receiver public key is there. So, get the receiver public key and encrypt the message using the receiver public key and send the ciphertext to the receiver. Okay. Now, if we keep this just like this, then there is a problem. The problem is, so if it is openly accessible to anybody, so if so an attacker can go and can change the public key of a person. So, attacker change the public key of this Bob, say. So, you can change just 2 bit, then whole system will be disturbed. Then if Alice encrypt a message using this wrong public key of Bob, then Bob will not able to decipher it. Bob will not able to get the plain text which is sending by the Alice. So, this is the, so this we cannot keep just public just like this. So, then what is the solution? Solution is we can hire a third party which is a authority or the trusted party who can control, who can maintain this. So, a third party or some authority, trusted authority, who can maintain this file. This is pkd.doc, some file, who can maintain this file. And if I have to get the public key of somebody, I will ask this authority, hey, give me the, because then otherwise this file can be made read only mode. Then I can only read the file, I should not able to write anything on the file. So, if I have to add my public key in the file, so suppose I have changed my public key. So, I am going to, so I was having a public key over here, Saurabh, I was having a public key over here, now I change the public key. So, this key change is a common thing, because say for example, suppose my corresponding secret key is revealed and I am fearing that maybe it got it known to somebody. So, now I am going to change this public key private key pair. So, I again run the setup phase of the public key encryption, public key crypto system, and then I got a new public key. So, I have to change the old public key. So, what I will do, I will contact this trusted authority who is having this control on this, who is maintaining this public key directory, and I will send my public key, and the trusted authority just change that new public key, replace this, replace my old public key by the new public key. Okay. So, again that so how trusted authority will so trusted authority can publish this public key in a book form, like we have a telephone directory, telephone book, the big yellow book, telephone book. So, like this periodically this trusted authority can publish this book in order to have that bottleneck, like if everybody is asking, hey, what is the public key of my sender, my receiver, then so it will be a headache for the trusted party. So, to avoid that, it can publish the public key over a hard copy or some sort of PDF file or something. Okay. So, that those are basically read only. So, nobody can change there. Okay. So, this is one way, and another way is, so this scheme is clearly more secure than the individual public announcement, but still it has problem because so this is the scheme. So, we are hiring a public key authority which will be having this maintaining this public key directory. Okay. So, so this is basically we are trusting the authority now, and also authority having a bottleneck to if he has to give the public key to the all the asking sender. So, to avoid this, so we introduce the concept of certificate, public key certificate. So, this is basically so public key certificate. So, basically this is an alternating approach to get the public key. So, the trusted party, the public key authority will issue the certificate, and each certificate containing a public key and the other information like some timestamp, and created by a certified authority, and it is giving to the participant with the matching private key. So, suppose Alice and Bob. So, Bob is having this public key private key pair, okay, and there is a trusted party here, say authorized party, author we can say, who is giving the certificate. So, what Bob can do? Bob can send a message to this. Bob can send Bob's ID of Bob along with the public key of the Bob to get the certificate. Now, the authority is having its own public key private key pair, author, D author. So, this is the authority's public key private key pair. So, now Bob has to get its certificate, public key certificate. So, what Bob will do? Bob will send or along with a timestamp, some session, say for today's date, it could be date. For today, this is the certificate of my for today. So, it may valid for some time. So, we will come to a standard of the certificate. So, this is basically a time, and this is the ID of that person participant, and this is the public key. It is sent to authority, and what authority will do? Authority will generate the certificate by signing on this. So, signing means authority has to encrypt this using authority's secret key. So, T ID of B EB. So, this is the certificate of Bob. This is the certificate of Bob. So, if Alice has to get the certificate, Alice has to do the same thing. Alice has to send. So, Alice also, if Alice has to send a certificate from the authority, Alice has to say, so Alice has to generate Alice public key private key pair. It could be RSA, it could be anything. So, it is a public key crypto system. So, now Alice send a timestamp along with ID of Alice and along with the public key of Alice, and then the authority will send back the certificate, which is basically C of A, Alice certificate, which is basically the digital signature on this message. I mean, so this is basically encryption of, so digital signature. So, it has to be by the private key of the authority, key, ID of A, E of A. Okay, so, this is the certificate Alice will receive after asking from the authority. So, in this way everybody is having their own certificate. Okay. Now, so this is the certificate generation from the authority. Now, after getting the certificate, what Alice, so now suppose Alice wants to communicate with Bob. So, Bob is having EB public key private key pair. Now, Bob having the certificate, which is basically signed by the certified authority. So, this is the digital signature D of auth, some timestamp, ID of Bob and the public key of Bob. So, now Alice wants to send a message to Bob. So, Alice asks Bob certificate. So, Bob will send this certificate to Alice CA, and what Alice will do? Alice has to verify this is Bob's certificate or not. So, for that, so this is signed by the authority. So, Alice has to check this signature. So, for that Alice need to decrypt it using authority's public key. So, what Alice will do? Alice will decrypt it using authority's public key on this CA. So, this is basically give us this part. So, this is basically D of E auth and this is basically E of D auth T E of B. Okay. Now, these two will cancel, it will give us T of ID of B and E of B. So, now Alice will check the time. Okay, this time means it is certificate is current certificate or not, some sort of time stamp is there. So, Alice will check this time and also Alice will check this ID of the Bob. Okay, so this is the ID of the Bob. So, this is really a Bob certificate and Alice, then Alice will get this EB, the Bob public key, by seeing the certificate. Okay. Now, after getting this Alice, after getting this Bob public key, Alice can choose a message and encrypt the message using Bob public key and send it to Bob. Okay. So, this is the way we can avoid to contact the authority in order to get the public key of the receiver. So, by seeing the certificate we can get this. Okay. So, similarly, if there are other party like say ROV. So, everybody is having their every participant is having their certificate, which is issued by the trusted party or the authority. So, Alice, Bob, Palash, Rob. So, everybody is having their own certificate CA, CP, this is CB, CA and CR. Okay. So, now if and this was issued by the trusted party or the authority when I ask for the certificate, and this certificate contain what? This contain the timestamp, the valuation of the certificate, how long it is valid kind of thing, and also this contain the ID of the participant, and it contain the public key of that participant, and it is digitally signed by the authority. And now, if a person wants to communicate, suppose Rob wants to communicate with Palas. So, Palas has to provide the certificate to Rob, and Rob will check whether this is the Palas certificate by checking the time and ID, and then Rob will get the Palas encryption, Palas public key, and Rob will encrypt the message using Palas public key and send it to Palas. Okay, so, this is the way we just generate the certificate. So, each certificate, as we said, each certificate containing a public key and the other information is created by the certificate authority, and it is given to the participant and with the matching private key. So, a participant convey this key information to another by transmitting the certificate. Other participant can verify, the receiver sender can verify that the certificate was created by the authority. Okay, so, 4 requirement can be placed here. Any participant can read a certificate to determine the name and the public key of the certificate owner. This is the first requirement, and the second requirement is any participant can verify the certificate originated from the certified authority, and it is not counterfeit. Okay. So, it is not a false certificate. So, this verification can be done, should be done by the any participant. Only the certified authority can create and update the certificate. So, suppose currently I have a certificate. Now, I am changing the public key, or I want to change the because I am guessing that my corresponding secret key has been revealed. So, what I do? So, this is the trusted party or the authority. So, which is having okay. So, this is the public key of the authority, private key of the authority. So, suppose this is me. So, I was having a private key and public key pair, and I was having also a certificate which was containing this. This was digitally signed by the authority and was having a timestamp along with my ID and my public key. Okay. Now, suppose I fail to change my public key, because I am fearing that maybe my secret key is revealed. So, I want to again run that setup. Suppose we are in RSA setup, RSA crypto system. So, I want to run RSA setup. So, again I do this PQ and then n is equal to p into q like this, then I choose 2 EB such that E is congruent to 1 mod phi n. Okay. So, phi is basically p minus 1 q minus 1, and then this is my public key, this is basically ES, and this is my corresponding secret key, new secret key. Now, so now this I want to so this setup I run, because I feel that I should change it, I should change my public key. So, I run this setup and I got the new setup public key private key pair. Now, I send a request for a new certificate to the authority. So, I have a timestamp, maybe today's time along with the today's date along with the time, and I send my ID and I send my, this is the say new, the current new public key. So, what authority will do? Authority will do the same thing, authority will digitally sign on this. So, E of D of auth along with T star ID of S along with E star, and this authority will send it to me. So, now my certificate is this CS is now replaced by CS, CS is now replaced by CS star. So, this way I can change the certificate, I can update the certificate, and this can be only done by the authorized person. So, this is the example. So, this is the timestamp, this is the ID of A, this is the public key, and this is digitally signed by the authority. And so, this CA is the certificate of A, and D auth is the public private key of it. So, the authority is digitally signing on this message. So, this message is containing timestamp, ID and the public key of the participant. Okay. And then this can be verified by this way, which we have discussed. So, this is just a, so this is the public key of the authority, which is public, anybody can have the access of this. So, he or she will take this public key and decrypt this certificate of A and check, getting this and check whether this is timestamp is okay and ID, and get the secret key of this. Now, we will come to a standard certificate standard, which is called X509. So, it is basically a standard. So, since it is a standard, it must have some criteria, like what should be the, what are the field it should have. So, we will just go to that. So, this is a certificate standard. So, this is basically used RSA and MD5, and it was initially issued in 1988, and then it has some variation. So, this is the next variation 1993, and then this is the revised variation again after 1997. So, this is the certified user certified generated by the CA have the following characteristic. Any user with access to the public key of the CA can recover the. So, this is the basic criteria of a certificate. So, no party other than CA can modify this directory. So, let us go to the figure. So, it has this, these are the field it has. So, version, which of the version, serial number, signature of the trusted party, and then issuer name. This is certificate is X500. So, that is the name of the issuer, we can say. Period of the validity. So, how many days you want this certificate to be valid. So, that field also be needed. Then the subject name, the name of the user or name of the participant. Then the public key information, we need to keep the public key into the certificate. So, that is the public key of the participant, and the issuer unique identification, then the subject unique identification extension. So, then the signature. So, this is the picture. So, this is basically having, these are the fields, the version, certificate serial number, the signature algorithm we are using, whether we are using the RSA signature, Elgamal signature, that should be mentioned there, issuer name, period of validity. So, this is basically, and we should have the public key of the participant. So, this is basically called X509 certificate standard. Okay. So, so this is the certificate standard, and everybody can have their own certificate in order to communicate in a public key crypto system, in order to encrypt, decrypt in a public key crypto system. Thank you.